Let's go ahead and do an example. Example 2. Okay, we will let f, our vector field of x, y, z, we'll let it equal to xy, xz, and yz. We will let S be the surface parameterized as follows. Parameterized as follows. P of t theta is equal to t cosine theta, t sine theta, theta, where t is going to run from 0 to 1, and theta is going to run from 0 to 3 pi. Okay, what we want you to do is to find the integral of f over this surface. Great, should be no problem at all. Okay, so let's go ahead, and I actually should have started this on another page. It's not a problem. I'll just rewrite everything that I need to rewrite. Let me go ahead and write the formula itself, always a good idea. So I need to go, let me do it over here. So the integral of f of p dotted with n dt du. Okay, well, let's go ahead and form f of p. Actually, you know what? I'm going to go ahead and write f and p over again. So f is equal to xy, xz, and yz. And my parameterization of t and theta is going to be t cosine theta, t sine theta, and theta. Therefore, my f of p, so I'm just going to put, this is my x, this is my y, this is my z. Let me go ahead and go to blue ink here. X, y, z. Wherever I see x, I put this. Wherever I see y, I put this. Wherever I see z, I put this. So I end up with the following. I end up with t squared sine theta cosine theta, theta t cosine theta, and theta t sine theta. And I certainly hope that you're all confirming this for me. Now I go ahead and I take dp dt. Again, just running through it. I need this, I need this. I just have to go through this step to get what I need. So I take the partial of the parameterization with respect to t, and I end up with cosine theta, sine theta, and 0. I'm going to take the partial of the parameterization with respect to theta, and that's going to be minus t sine theta. It's going to be t cosine theta, if I'm not mistaken, and it should be 1. Okay, now of course I have to form the cross product of these two because that's going to give me n. So dp dt cross dp d theta, that is going to be my symbolic determinant. So I've got cos theta sine theta 0 minus t sine theta t cos theta and 1. So when I form this determinant, I end up with the following. I end up with sine theta cosine theta and t. Good. Okay, so this is going to equal n. This is my n. So now I have n, and I have f of p. Now I'm ready to go ahead and construct my integral. So my integral is equal to, and of course they gave me the range. They said t goes from 0 to 1, and they said that the theta goes from 0 to 3 pi. So I go ahead, I have my upper and lower limits of integration. So let me go ahead and do t first. That's going to go from 0 to 1. And let me go ahead and do theta next. That's going to go from 0 to 3 pi. So now I have my f of p, which is right here, and I have my n, which is right here. I need to form the dot product of f of p dot n. So I have to form, I could do this times this, plus this times this, plus this times this. That's what I'm doing. So my integrand is going to look like this. T squared sine squared theta cosine theta plus this times this plus theta t cosine squared theta plus theta t squared sine theta. And I did theta first, so this is going to be d theta, and dt is going to be last. Okay, and when I solve this, I end up with 9/8 pi squared plus pi. That is the integral of that particular vector field over this particular surface with that particular parameterization. That's it. It's that simple.